Okay. This is just in addition to the previous recorded video, because there was a part there where I changed from my PowerPoint presentation slide to Jamboard, and apparently the Jamboard was not shown on the screen, or you cannot see it while I was doing the actual discussion. So this is just to show you what I was discussing during that part of the recorded video. So in here, I have a glucose molecule, and we are going to identify where is carbon 1 until carbon 6. So in order for you to do that, you have to locate your oxygen, because the carbon next to the oxygen is automatically carbon 1. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. The same here in this next glucose molecule. So if this is your oxygen, this is your carbon 1. This is your carbon 4, and this is your carbon 6. So the reason why I'm teaching you where carbon 1 is, where carbon 4 is, because your glycosidic bonds are usually formed between carbons 1 and carbon 4, or sometimes they are formed between carbon 1 and carbon 6. So you need to identify where is 1, where is 4, and where is 6. So for example, I have here one glucose molecule, and this is carbon 1. I'm going to add another glucose molecule to form maltose, and it will be formed using an alpha 1,4 kind of linkage. So if this is carbon 1, automatically it will form a glycosidic bond with carbon 4 in a dehydration process. So let's apply this when it comes to your starch. In your starch, it is actually formed by an alpha 1,4 linkage. So it means that this is your carbon 1 and this is your carbon 4. Therefore, the glycosidic bond is formed between 1 and 4, and it is facing down. Okay? And then this is another carbon 1 and carbon 4. So another glycosidic bond here. And this is another carbon 1 and carbon 4. So another glycosidic bond here. So your starch, all of the glycosidic bonds are facing downward, which is different when it comes to your cellulose. In your cellulose, what happens is that your glucose molecules are not facing the same way. In your starch, if this is one glucose molecule, this is another glucose molecule. So they're always facing upright and they are facing the same way. But when it comes to your cellulose, it's not what happens in your in your cellulose. In your cellulose, if this is glucose 1, glucose number 2 is facing the opposite side. So if you will notice here, glucose 1 here is facing upright, and then glucose number 2 is facing downward. The same here. Your oxygen is here, so it is facing upwards. But the oxygen is here on the second glucose molecule, so it means it's facing downward. This one is facing upward, and then this is another facing upward. So in this case, the glucose molecules will have a glycosidic bond that's facing downward. But in this case, the glycosidic bond 1, 2, 3, 1, 2, 3, 4, in this case, it will be like this. So it's going up. 1, 2, 3, 4, between here and here. So this is, sorry, so that you're not confused. It's between here and here. Okay, so that's what happens here. The alpha 1,4, the beta 1,4 is formed upwards here, and then here it goes downwards. Here it goes upwards, and then here it will eventually go downwards. So it's alternating up and down between the glycosidic bonds. And this is one of the reasons why your cellulose can be stacked up with one another. It's because if you can see, both glycosidic bonds here are facing upwards. So if you put them on top of one another, that's possible. In here also, the glycosidic bonds are both facing downwards. So if you stack them against one another, they're like Lego. They fit each other. So you can put them on top of one another. So your cellulose are able to build straight sheets, whereas your starch, because all of them are facing downwards and you cannot put them on top of one another. So eventually they start to bend, and then those bend will now form helices or helical rods. Okay, so like I said, this is just in addition to the earlier recorded video. because you couldn't see my Jamboard way back in the first video. So yeah, that's it.